go through pH calculations. So when you want to calculate the pH of an acid, I use the word CHOP. This word CHOP, C stands for concentration of the acid, then the C stands for concentration of the acid, the HO stands for the concentration of hydronium ions, the concentration of hydronium ion, then the P stands for the pH. And the pH formula is this. This is the formula for pH. So pH is equals to negative log concentration of hydronium ion. pH is equals to negative log concentration of hydronium ions. Right. Then for base, we say I use the word cook. C stands for concentration of the base, then OH is the concentration of OH minus, K stands for the KW formula, which allows you to convert from concentration of hydronium ions to concentration of OH ions or hydroxide ions. And this happens at 25 degrees. That is the room temperature. Then P stands for pH formula, which is that. But let's get into it and see the examples. So in this example, we want to calculate the pH. So they say a beaker contains a 0.025 mole per cubic decimeter solution of hydrochloric acid. So we know that this is a hydrochloric acid. So I use CHOP. I'm going to use CHOP. First of all, I'm going to check if I have the concentration. Yes, I have the concentration of the acid. Then now I have to go and find the concentration of hydronium ions. So this is concentration of hydronium ions. I have to find what the concentration of hydronium ions is. And to find the concentration of hydronium ion is just a ratio between the concentration of acid and hydronium ion. So you just say HCl is 2 hydronium ions. To find the ratio, you just ask yourself how many hydrogens are there in the acid. You have got 1 hydrogen, so the ratio is 1:1. Remember, concentration of hydronium ions is the same as concentration of hydrogen ions. I'm saying concentration of hydrogen ions, H plus, is the same as saying the concentration of hydronium ions. So that's why I ask myself how many hydrogen ions, because whatever the number of hydrogen ions are there will be the same as the hydronium ion. The concentration of hydrogen ions will be the same as the concentration of hydronium ions. That's what I'm saying. So that's why I asked myself how many hydrogens are there, how many hydrogens in the acid, right? So now when we check the ratio is 1:1. Now the concentration is 0.025. That is the concentration of the acid. Now the concentration of hydronium ions will be what? Since the ratio is 1:1, it means that the concentrations will be the same, or you just simply cross multiply to get the concentration of hydronium ions. So the concentration of hydronium ions is equals to 0.025 mole per cubic decimeters solution. Right now, I got the concentration of hydronium ions. Now I have to find pH. So the pH formula says pH is equals to negative log concentration of hydronium ions. Concentration of hydronium ions. And negative log, I now substitute. Concentration of hydronium ions is 0.025. So the pH will be 1.6. So you can check here. I use square brackets here. This square brackets means concentration. But when you substitute the concentration, you must use circle brackets, which is round brackets, when you now substitute a value. Okay? So let's check. Let's look at the second calculation. How we go about. So this is what a beaker contains 0.08 mole per cubic decimeter solution of hydrochloric of sulfuric acid. This is a sulfuric acid, right? So what are we going to do? We are going to use a chop. We're going to chop the acid. First of all, do I have concentration? Yes, I have concentration. I put a tick there. Then I will now want, what do I want? I now want this, the concentration of hydronium ions, right? So let's do it. I use a ratio to move from concentration of acid to concentration of hydronium ions, or you must use a ratio. So I'm going to say H2SO4 is to hydronium ions. Now, to find the ratio, you ask yourself, in this acid here, how many hydrogens are there in this acid? How many hydrogens are there in this acid? There are 2 hydrogens there. So the ratio is 1:2. 1:2. The reason we say 1, the 1 is for the one acid. We only have one acid. So in one acid, we have 2 hydrogens. That's what he is saying. And because we have 2 hydrogens, now it means even the hydronium ions will be 2. Right? If 2 hydrogens are being produced from one acid, then also 2 hydronium ions are being produced from one acid. That's what it actually means. Now, the concentration is 0.08, right? So what is the concentration of hydronium ions? Okay, now you can cross multiply. If you cross multiply here, you cross multiply, so this will mean the concentration of hydronium ions is equals to 0.16, because 2 multiplied by 0.08 is that. This multiplied by 1 is this. Then 2 multiplied by 0.08 is that. We say mole per cubic decimeter. Don't forget to write units. Now, after getting this concentration of hydronium ions, now we can go to pH. We got the concentration of hydronium ions. Let's find the pH now. You now find pH. So you say pH is equals to negative log concentration of hydronium ions. This is equals to negative log. The concentration of hydronium ions is 0.16. When I substitute the value, I now use round brackets. So the answer is 0.80. 0.80. That is the pH of the solution. Right? Let's have a look at this one. It says a 500 cubic centimeters solution of hydrobromic acid has a pH of 3. Now you calculate the concentration of hydronium ions. So we know that for pH of an acid, because this is an acid, for pH of an acid we use CHOP. We use CHOP. But now already we are given the pH. We are already given the pH, meaning we are doing a reverse method. We are reversing until we get there, right? So we already have pH. So I now use a pH formula already here. So I use the pH formula, which says the pH is equals to negative log concentration of hydronium ions. The question says calculate the concentration of hydronium ions. Okay, so this is what the formula says. Now already our pH is 3, so you put a 3 in the place of pH, log concentration of hydronium ions. Now to make this the subject of the formula, to make hydronium ions the subject of the formula, you must know that concentration of hydronium ions, concentration of hydronium ions is equals to 10 to the power negative pH. Right? Concentration of hydronium ions, if you make it the subject of the formula in this situation, is equals to 10 to the power negative pH. That's how you make this one the subject of the formula. But already our pH, we have it. What is our pH? Is 3. So I put 3 there. Right? So I put 3 there, and then mole per cubic decimeter. Right? If you want, you can write it in decimals. In decimals, that will be 0.001 mole per cubic decimeter of that is the concentration of hydronium ions. So we got it. We are done. We go to question. We are now addressing the other one. Okay. We now want to calculate the mass. We want to calculate the mass. Right. Now, we said the concentration of from the CHOP formula, from the CHOP, right, we said we already calculated the concentration of hydronium ions. So we already have this and we have this. All right. Now, I'm going to do this. To calculate mass, the formula is N to calculate the concentration. I'm going to use this formula here. Okay. I'm going to calculate the concentration, then volume and molar mass I already have, so that I can calculate the mass then. Right. Alternatively, I can decide to use this formula to get number of moles. Then after getting the number of moles, use this formula. First get the number of moles, then calculate the mass there. But I'm going to use this one that combines everything in one step. So I'm going to use, I'm going to do this. I'm going to first find the concentration of the acid. Then after finding the concentration of the acid, I know that now C is equals to M over MV. So I will be having concentration, molar mass, and volume. So I just calculate the mass. Right, so let's find the concentration. Since now we calculated the concentration, previously we calculated the concentration of hydronium ions as 0.001 mole per cubic decimeter. That was the concentration of what? Of hydronium ions. Now, I'm going to use the ratio to get the concentration of HBr. So I say HBr is to hydronium ions. Right. What is the ratio? How many hydrogens are here? There's one hydrogen, so the ratio is 1:1. Okay. Then now, I already know the concentration of hydronium ions. This is the concentration of hydronium ions. Then now, what is the concentration of HBr? We now want to see the concentration of HBr. The ratio is 1:1, so the concentration of HBr will be the same as the concentration of the hydronium ion. So 0.001 mole per cubic decimeter. Now, I can apply that formula there. I can use this formula there. See, okay. Now, concentration is equals to mass over molar mass times volume. The concentration is 0.001 is equals to mass over. Then we need to know the molar mass of HBr. So let me continue in the next slide. Let me continue in the next slide. So we said C is equals to mass over molar mass times volume. But the volume that we are given there is as follows. It is the 500 cubic centimeters. We have got 500. These 500 cubic centimeters must be converted to cubic decimeters by dividing by 1,000, so that it is now 0.5 cubic decimeter. That is the volume that we are going to use. It must be measured in cubic decimeters. Okay? So we say, write C is equals to M over MV. The concentration is 0.01 is equals to mass. The volume, we know it to be 0.5. The molar mass of HBr. The molar mass of HBr is hydrogen. Hydrogen is 1. HBr is I think it's 80. It's 80. So the molar mass is 81 grams per mole. Okay. Grams per mole. So put 81 here. Now to get the mass, you just simply cross multiply. And then this is what we get for HBl. Okay, this one, how do we do it? We say 400 cubic centimeters solution of sulfuric acid has got a pH of 2. Now we say 1.4. Calculate the concentration of hydronium ions. Okay, so we know this is an acid, so we use what? CHOP. We already have the pH, right? So ours is to get there. Now, what are we going to do? Say, okay, pH is equals to negative log concentration of hydronium ions. Then our pH is 2, is equals to negative log concentration of hydronium ions. To make this the subject of the formula, you say concentration of hydronium ions is equals to 10 to the power negative pH. And what is our pH in this case? Is 2. pH is 2. So this is the same as 0.02 mole per cubic decimeter. Mole per cubic decimeter, if you want it in scientific notation. Right, now we got the concentration of hydronium ions in this way. Right, now what do they want? We now want the concentration of the sulfuric acid itself. So we say, okay, sulfuric acid, find the ratio. Sulfuric acid is to hydronium ions. You ask yourself, how many hydrogens are here? Hydrogens in is this 1:2, the ratio, because there are 2 hydrogens here. In one acid there are 2 hydrogens, so the ratio is 1:2. Right, now the concentration now, the concentration that we have is the concentration of hydronium ions, which is 0.02. Now, what is the concentration of sulfuric acid? So we just simply cross multiply here. Simply cross multiply. Bam. If you cross multiply, then you will end up dividing by 2. So the concentration of hydronium ions of sulfuric acid will be equals to 0.01 mole per cubic decimeter. Now we are coming to the pH of KOH, which is a base. Right? Remember, a base will produce OH minuses, whereas an acid produces hydronium ions. Okay. So For a base, when we calculate the pH, we use Cook. You cook. Right. So now, check. You see, OH is for base. OH is for base. So this is the concentration of the base. This will be the concentration of OH minus. Then this is the KW formula. And this is the pH formula. Right? So let's follow it. So, what do we see? I write the word cook so that I'm guided. Okay, what do I have? I have the concentration of the base itself. Now, what am I looking for? I'm looking for the concentration of hydronium ions, of OH minus. So I'm asking myself, how many OH minuses do I have? So I just simply do a ratio there. I say KOH is to OH minus. Right, so I'm asking myself, how many OH minuses are there in the base? You've got 1. So the ratio is 1:1. All right. So on the left hand side, the ratio, this will be 1. This, and then this number can change. This second one can change, but this one is always 1. Right. This is always 1. Now, we say the concentration is 0.075. Now we want to know what is the concentration of OH minus. OH minus. Since the ratio is 1:1, so the concentration will be the same. So the concentration of OH minus 0.075 mole per cubic decimeter. All right. Then now, where do we go? We go to the KW formula. We go to the KW formula because already I've got the concentration of OH. I must go to the KW formula. The KW formula says this is the KW formula that we are talking about. Right. It happens at 25 degrees room temperature. So we are going to move from the concentration of hydronium ions, of hydroxide ions, to concentration of hydronium ions, so that we can calculate pH. Value. There. So that's what will happen then. Oh, that's what needs to happen. We'll get there, then we go there. We come to the pH formula there. Right. So that's what we're going to do. This is the KW formula. Right. So the KW formula says what? Says KW is equals to the concentration of hydronium ions so this is the KW formula. Of course, in the formula they say 1 times 10 to the power negative 40. But anything multiplied by 1 is that number. So that's why I wrote it like this. So, but you can copy it exactly as it is. Okay. So here I'm just doing it for space. That's why the 1 I did not write it, because if you multiply anything by 1, it is that number. Now I substitute, do my substitution. The concentration of hydronium ions, which we do not know. Okay. So there, you substitute. This is the concentration of OH minus. The concentration of OH minus, you put it there, substitute there. So you see that one, round brackets. You must use round brackets when you substitute the value now. Right? You divide both sides now. You divide both sides by 0.075. 0.075. Okay? And you will get an answer of so you get an answer of that, right? So this is the concentration of hydronium ions. Now you, after getting now the using the KW formula, then now use a pH formula. Okay, now pH, you say pH is equals to negative log concentration of hydronium ions. Right? Now we substitute, we say this is equals to negative log 1,33 times 10 to the power negative 13. Sorry. There is supposed to be 10 to the power 13 in the calculator. That's what we get. Power 13. Okay. Get to the power 13. And then we can then get our answer. The pH is equals to, you get 12.88. Of course, pH does not have units. Okay, of course, this marks wrong. This is about 8 marks question. So there was something there. So this is how we do the pH of a base. Now it says a flask contains this concentration of calcium hydroxide, which is a base. Determine the pH. We use what? We cook the base. So we cook the base. Let's cook the base. What do we have? We have concentration of that base. So I'm going to get here to the concentration of OH minus using a ratio. So I see calcium hydroxide is to OH minus. Okay, what is the ratio? So the question is, how many OH minuses do I have in this one calcium? We have got 2 of them. One, so the ratio is 1:2, because we have got 2 for OH. 2 OH in 1 calcium hydroxide. All right. So the concentration is 0.075. 0.005. Now we want to know the concentration of OH minus. Right, you cross multiply here. The concentration of OH minus is equals to 0.01 mole per cubic decimeter. After getting the concentration of OH minus, I go to the Kw formula. Now I have to go to the Kw formula, okay? Kw is equals to the concentration of hydronium ions multiplied by the concentration of hydroxide ion is equals to 10 to the power negative 40. Okay? Now, we start substituting. Concentration of hydronium ions 0.01 is equals to 10 to the power negative 40. Right, then you divide both sides by 0. You now divide by 0.01, divide by 0.01 both sides. So you get the answer of that magnitude there. Right, I wrote it in scientific notation. Okay, mole okay. So now, after getting this, we have used the Kw formula. Now what do we use? We use the pH formula. We apply pH formula, which is pH is equals to negative log concentration of hydronium ions. Now, this is equals to negative log 10 to the power negative 12. Okay. Then we punch into a calculator what the pH is. So the final answer is 12. Is the final answer. So the final answer is 12 there. The pH is 12. Right, we look at this one now. 7 grams of KOH is dissolved in a 500 cubic centimeter water. Calculate the concentration of hydroxide ions. Now we want the concentration of hydroxide ions. So I know that this is KOH and this is a base. KOH is a base, so I must cook the base. cook the base. Right, do I have concentration? That is the first question. Do I have concentration? No, I don't have. The aim is to get to the pH, right? I don't have concentration. I must calculate the concentration, okay? So I must find a way of calculating concentration. So I have to calculate concentration when I'm given what? Grams. All right. So I know that concentration is equals to mass over molar mass times V. Right. The molar mass of KOH. Let's see. The molar mass of KOH will be equals to K. So the molar mass of KOH is 56. Now, this is equals to the mass is 7. The molar mass is 56. Right. And this must be divided by 1,000 to convert it into cubic centimeters. That 500 there. So it will become 0.5. So the concentration there is that. Okay. Then now I now find the concentration. This was the concentration of KOH. Okay. Now I must find the concentration of OH. I must find the concentration of OH. We use the ratio KOH is to OH. Alright. Now, what is the ratio? How many OH are there in the base? I have 1. So the ratio is 1:1. The ratio is 1:1. And we know that the concentration of KOH is 0.25. Therefore, what will be the concentration of OH minus? So the ratio of 1:1 means they will be the same. So the concentration of OH minus is equals to 0.25 mole per cubic decimeter. So now they say, let's calculate the pH. So we calculated, already we know that the concentration of hydronium ions was 0.25 mole per cubic decimeter. Right? That was the concentration of OH. Now, to find the pH, remember we're still following what? We're still following cook the base. I already know the concentration of the base. I know the concentration of OH minus. Now we have to use KW formula so that we can get to our pH, right? Kw formula, when you apply it, this is Kw is equals to concentration of hydronium ions times OH minus is equals to 10 to the power negative 14. Right? That's what we have. Okay. Now we substitute. Is this equals to concentration of hydronium ions multiplied by, we must substitute the 0.25 is equals to power negative 40. Right? Then we divide both sides by 0.25 divided by 0.25, both sides. So we get that one then. This is the concentration of hydronium ions after using the Kw formula. Now I can use pH formula. So I say pH is equals to negative log concentration of hydronium ions. So negative log is 4 times 10 to the power negative 40. And the answer will be 13.40. Now you are given pH, and then we have to reverse and go back. Okay? So in this case now we're going to say, they say the pH of 250 cubic centimeter solution of KOH is 13. Right? We say determine the concentration of OH minus. So what do? We know that we cook the base. Okay. What do I have? I have pH already. Now I go and use the pH formula. Take my pH formula. pH is equals to negative log concentration of hydronium ions. Take your pH formula. Right, so then we are going to substitute. Our pH is 13 is equals to negative log concentration of hydronium ions. Then to make hydronium ions the subject of the formula, what do? We say concentration, this is 13. of hydronium ions is equals to 10 to the power negative 13. So you say 10 to the power negative pH. So what do you get? So mole per cubic decimeter. So that's the pH that we get. Right. Sorry. The pH that we have is 13. Then this is the concentration that we get. Then use that concentration is the concentration of hydronium ions. We want the concentration of hydroxide ions. So it means I must go to the Kw formula. So from here, I now use the Kw formula. So we are moving in reverse. We are moving here, going backwards. Kw formula. So I take the Kw formula now. I'll say Kw is equals to concentration of hydronium ions multiplied by OH minus is equals to 10 to the power negative 14. Alright, now we start substituting. We say now the concentration of hydronium ions multiplied 10 to the power is equals to 10 to the power negative 14. Then now we substitute the concentration of hydronium ions. The concentration of hydronium ions is this, you substitute it there so that you get the concentration of hydroxide ions. Okay, so now we divide both sides. We divide by 10 to the power negative 13, 10 to the power negative 13, both sides. Divide both sides by 10 to the power negative 13. So we get an answer of this 0.1 mole per cubic decimeter of hydroxide ions. Okay, then it says calculate the mass. Now it says calculate the mass. Okay, now when we check, we have got Cook already in our Cook. We got this, we used this, we used that. Now, they want mass. If we want mass, I'm going to use the formula. I'm going to get concentration first, then use the formula that says concentration is equals to mass over molar mass times volume. I'm going to use that formula there. So, what is the concentration? Now, the concentration of KOH is to the concentration of OH minus. What is the ratio between the two? Now, to get the ratio, we will have only one OH in this base, okay? So the ratio is 1:1. And we know that the concentration was 0.1. So the concentration of KOH, what will be the concentration of KOH? C KOH is equals to 0.1 mole per cubic decimeter. It will be the same because the ratio is 1:1. Right. So now this volume must be divided by 1,000. It must be divided by 1,000. This must be divided by 1,000. And it will form 0.25 volume. Okay? So now when I substitute into this formula, let me just do this. When I substitute into the formula, let's do substitution into that formula there. We see the concentration is 0.1. Sorry. Zero 0.1 mass. Then we know the molar mass of KOH is K is 39 plus 16 plus 1. That would be 56. That would be 56 grams per mole. Grams per mole. So here I'm going to put 56 0.05 there. Then we check. So we substitute there. You cross multiply. This is 56. This is 56. This is 56. 56. 56. 56. 56. Then we cross multiply. This is 0.25. Let's not confuse it. 0.25. Okay, that was our volume. Then so the mass is equals to 1,4 grams. The mass of KOH is the mass is 1,4 grams of KOH. And then we are done. We can look at the next slide. Now we look at the last question. Now, the pH of a 200 cubic centimeters of barium hydroxide is 12. Determine the concentration. So we want to determine the concentration. Right. We know that this is a base, so we cook the base. We cook the base. We cook the base. Right. Now, what do we have? We already have the pH. We already have the pH. And then we are going to use pH formula. That's where we start. We have the pH. Then we use the pH formula. So it says pH is equals to negative log concentration of hydronium ions. This is equals to we check them. The pH is equals to negative log concentration of hydronium ions. Now, the pH is 12. Negative log concentration of hydronium ions. To make hydronium ions the subject of the formula, say 10 to the power negative 12 mole per cubic decimeter. Then we substitute, so we make the hydronium ions the subject of the formula. When we make it the subject of the formula, we just say the concentration of hydronium ions is equals to 10 . So that now we see we go to KW formula. We go to the KW formula because we are moving in reverse, right? We're moving in reverse like this. Go to the KW formula. We say KW is equals to concentration of hydronium ions multiplied by concentration of hydroxide ions, 10 to the power negative 14. The concentration there is 10 to the power negative 12. Hydronium ions, 10 to the power negative 14. Then the constant, you divide both sides. You now divide by 10 to the power negative 12, 10 to the power negative 12. That will give you the concentration of hydroxide ions is the concentration, so say as 0.01, right, mole per cubic decimeters. Right, this is the concentration of hydroxide ions. Now to get the concentration of barium hydroxide, you see now to 2, what is the ratio between the two? In one barium hydroxide, we have got 2 hydroxide ions. We have got 2 OH minuses in one base, right? So, and we know that this is the concentration of hydronium ions. So what is the concentration of the barium hydroxide? We want to know the concentration of a barium hydroxide. Then, so you do the calculation, you cross multiply. You cross multiply, then you simplify everything there. So that you will get an answer of concentration of barium hydroxide, the concentration of barium hydroxide. The concentration will be equals to 0.005 mole per cubic decimeter of barium hydroxide.